Question 4. The angle of depression from a kookaburra's feet to a worm on the ground is 40 degrees. The worm is 15 meters from a point on the ground directly below the kookaburra's feet. How high above the ground are the kookaburra's feet, correct to the nearest meter? We can use this right-angled triangle to model this situation. The vertical side of this right-angled triangle, which I've labelled with the pronumeral x, represents the height of the kookaburra's feet above the ground. And that's what the question is asking us to find. The horizontal side of this right-angled triangle represents the distance from the base of the tree, which is directly underneath the kookaburra's feet and the worm, and that's given as 15 meters. Now we can apply one of two things here, since we're dealing with a right-angled triangle, either Pythagoras' theorem or right-angled trigonometry. Now to apply Pythagoras' theorem, we need the length of two known sides, but we only have the length of one side, which leaves us trigonometry. Now it's given that the angle of depression is 40 degrees, but this angle is outside of this right-angled triangle. Now the angle of depression and the angle of elevation are identical, since they are alternate angles sitting on these parallel lines. This dashed line here is parallel with the ground, and this hypotenuse represents the transversal. So the angle of elevation is 40 degrees. So we have a known side, we have an angle theta, which is 40 degrees, and we want to know the length of this side here. So x represents the opposite side. This side, 15 meters, represents the adjacent side. So the ratio that we're looking at is opposite over adjacent, and referring to SOHCAHTOA, that's the tan ratio. So expressing this as an equation, we have opposite over adjacent, so x over 15 is equal to tan 40 degrees. We want to make x the subject. Now x over 15 is the same as saying x divided by 15. So we can move this 15 over to the other side by multiplying it to tan 40 degrees. So x is equal to 15 times tan 40 degrees. And evaluating this expression here, that's equal to 12.586 and so on meters. Rounding that value correct to the nearest meter, we get 13 meters. Therefore, the correct answer is option C.